This video is in a certain way following the more or less final video about the TRF receiver that works absolutely best on medium wave, say 800 kHz up to 1.6 MHz. I want to show some effects. First, important to tell that there is a combination of the coil here, antenna coil, the tuning capacitor from say 10 to 500 picofarad, and the capacitor that couples the antenna free hanging wire in my room, approximately 4 meters in. So there are 3 factors here. There are of course also many other factors. I'm not going to tell more about that now. What I wanted to show is the effects of the resonance peak. We are now receiving with this combination, this and this, a radio station in the Netherlands around 1.35 megacycles. And you can use to receive such a radio different coils, but one coil has better properties compared to another coil. That's what I want to demonstrate now. This is say the test coil. I've also used this coil, not complete, but a part of it, this part, only this part. The other part is shortcut. That can also be used for medium wave. This was also a good quality medium wave coil. All working around say 1.35 megahertz. Anyway, so the demo is now here. At first, I want to demonstrate the so-called hand effect. You hear that radio station? Let's tune in. It's now maximum. When I go with my hand to the coil, it gets more fierce. I have to keep the music not very long, because I could get a copyright claim from YouTube. Anyway, you saw the hand effect. That hand effect has also, when you touch the tuning capacitor, there's also a hand effect. It gets more fierce, the radio station, but also it can damp the tuning to a specific radio station. That's now realized here with this combination. Anyway, that was the first thing to show. Could be that when you make such a radio, you need here a plastic axis and a knob here, so that your hand does not get close to the tuning capacitor. Has everything to do with the typical properties of such a simple TRF receiver. Anyway, also there are other possibilities. I've showed that many times on my YouTube channel. Say for instance here a kind of shield of tin plate, and that connected to the ground, then the hand effect is completely gone. Anyway, more important is say the resonance peak, where what is happening there. Of course, when you want to tune to a radio station, it must be you want to tune to it as sharp as possible. And now I demonstrate this. Here I'm tuning now. So it is not very fierce, the radio station. What does it mean? It at least means that this radio, that this coil, that's what I mean, the quality is not as good as it could be. let me show it again. Let me show it, not again, but let me show what the effect is of sticking that ferrite rod in. Important to tell that when there is no ferrite rod in, the inductance of the coil, say the resonance frequency, is higher. Do I say that right? When there's no ferrite rod in, yes. The resonance frequency is higher. That means that when I stick this in, the frequency gets lower, and that means that I have to tune the tuning capacitor to get to the same radio station. So let's try. This was quite weak. Now I stick that rod in here, and the radio station disappears because it's no longer tuned to that radio station on 1.35 megahertz. But now I'm tuning here the tuning capacitor to get the resonance again on the frequency that I want to receive, that AM radio station. And let's listen. So you have to set the tuning capacitor to another frequency, but the effect is much better. That means that the Q, the quality factor of that coil, combined with that ferrite rod inside, is higher. So take the rod out. There's distortion anyway in the sound, but I've talked about it. Let's go back now to try to receive the same radio station without that ferrite rod. Here it is. Let's give it somewhat more high frequency amplification. Well, that's not possible at the moment anyway. Stick the rod in again and tune again via the tuning capacitor to the same radio station. So, much better results when the Q, the quality factor of such a coil, is higher. There is, of course, a formula to calculate the quality factor. I don't publish it. I never used it, by the way. My work is experimental. Of course, on a certain time when you work with all kinds of coils, say like they are here and here and here, you get an idea about the quality factor of coils. Say whether they can give a broad, whether they range to a broad frequency band or to a specific frequency, specific resonance frequency. Anyway, thanks for watching. When you want to make my radio that I've published, these are things to take in account. I have showed two coils that are usable. One with a ferrite rod and one without a ferrite rod. And the description is not in the text box, but I've pinned under in the comment section of the 4 videos how you can make that AM coil with a good quality factor. Thanks for watching. Always fun, these experiments.